This is the 2007 question 1b. A train accelerating uniformly from rest to a speed v. It continues at this speed for a period of time. So it looks like we've got a graph like this, up, continue at this speed, and then decelerate. We'll do a bigger version of this now. In traveling a total distance of d meters, so that's the area in there, the train accelerates through a distance of pd meters and decelerates through a distance of qd. P is less than 1 and q is less than 1. And we're asked to draw a speed time graph for the motion of the train. And then the average speed is this v over p plus q plus b. Find b. Okay, we'll fit the graph in here. So we're accelerating, continue at the same speed, and then decelerating. We're given the area of these first and last shapes. It accelerates a distance of pd meters. Pd, we've got top speed v, and distance qd meters is the deceleration, qd, and the total is d. So we have 3 time periods here. We have t1, t2, and t3. And we're given average speeds, and we know the average speed from our distance speed time triangle. Average speed, S for average speed, distance over time. So we're going to need to look at time here. So why don't we start with the area of these shapes? Half the base by the height, half t1 by v plus t2 by v plus half t3 by v. All of this is equal to d. So we know half t1 times v is the area, which is pd. So that would give t1 to be 2pd over v. We get t3, a half t3 times v is equal to qd. So we can get t3 is going to be equal to 2qd over v. And then what can we say about t2? Well, the total distance minus pd minus qd, that will be equal to the area of t2, or the distance traveled in t2, which we have as t2v. So I think it might be tidy to factor out this d here. D would leave 1 minus p minus q, and all over v would be t2. So they're the times. T1, T2, and T3 are the times. So distance over time. Let's look distance, which is d, divided by time, which is 2p d over v plus 2qd. Well, they're all over v actually. Let's just put them all over v. Just put one v in the middle. And then plus d times 1 minus p minus q. Is this where we're going? Well, there's a d and everything. So if I flip this bottom fraction upside down, the v will go on top and we'll have a vd, or just divide by d. We'll just end up with v on top, and all the d's will disappear if we divide every term by d. So hopefully this works out. 2pd plus 2qd plus d minus dp minus dq. So I have 2pd minus 1pd. So I have v over just pd. And the d's are gone. I'm being So here, these are gonna rub them out. And then that becomes a 1. This one doesn't want to go. So what do we look like? We have 2p minus p, which is just p. We have 2q minus q, which is just q, and we have the 1. So I think this is what they were looking for, v over something. V over p plus q plus b, and find the value of b. Excellent. We have it here, b is equal to 1.